Well. Thanks for everyone for joining. We are about to have our wake up period now. That we've got a couple of housekeeping procedures scheduled for the command module. Stirring the cryo tanks, switching around a battery charge, a fuel cell purging here and there. But pretty much right off the bat, just a few moments after wake up, we're gonna immediately board the LEM and start getting on with power ups. So it'll be an exciting day. It'll be an exciting day. Yeah, Arco here, our MJCI, made the lyrics for the song and passed it through uh in AI, which I'm pretty sure costed some money, but it's one of their hobbies to write music and then make songs out of it. They did the same thing for a bunch of flight streamers songs as well. So we are currently zipping along here through the rest of the sleep period, and we'll get right on to those few housekeeping procedures and boarding the lunar module. Didn't cost you anything. That's good. That's good. That is good. Yeah, I like Apollo 10. Keeps things direct, you know. You wake up, it's like it's the LEM day. You do whatever post wake up activities that are required, and then you just get in the LEM right away. There's no BSing around here. We do get a couple of landmark trackings spread out through LEM activation. Always hate when they do that, but unavoidable on these missions. Unavoidable. Like the Elijah song, yeah. Excited for LEM activity. That's great. We are gonna have our wake up now here. So it's dark. Let's turn some lights on. Just watch out for flying solid waste. Yeah. We'll be fine. Won't have much relative velocity. Alright, cycle those fans. Give our cryo a stir. You know, the traditional wake up procedures here. Disable our battery charge. And there is no reason to vent, although we do have a slight accumulation of hydrogen gas now. It is not up to the point where we are instructed to do venting, so we will hold off on that. Activate our standard RCS configuration. And quantities are looking really, really good for today's flight. Hey, what's up? What's up, Owen? How's it going? You see, yeah, Jackson Tyler is, I don't know if you've seen any of his videos. He actually he gets the licensed music. He gets the good stuff. He gets the good stuff. And I'm sure it costs a pretty penny. Yeah. That cannot be cheap. 270 minus 15, minus 15. minus 15. 15, 30, 45. Puts me at about 225. 228 should be about right there. All right. Last steps before our boarding of the lunar module here. We've got a ECS redundant component check. And we've got our purge on H2 and O2. No subscription. You buy the license, except the problem is that you have to get the license from the publisher, the songwriter, and the recording people that recorded that specific version of the song. Yeah, yeah. But yeah, it's, you know, got some good stuff. I think my favorite one is in the Mercury program. I think my favorite one is in the Mercury program when they were doing the rocket launches and there were a bunch of explosions. The song that was selected for that one, that was a good song. I like that one. Go ahead and get some wide deadband hold again. We don't need to be this precise here. Yeah, with all the Atlas rockets exploding, I like that one, actually. Don't know why anyone wouldn't like that. It was a good song choice. I like it. Alright, Sucompressor 2 looks good. Pressure regulator A. Looks good. Pressure regulator B. Looks good. Good response from the accumulator. Good response from the pump discharge pressure. Waiting on that pressure equalization here. Accumulator still dropping. Ah, whatever. Whatever. That song was literally played in one of the space movies anyways. I think it was actually played for, October Sky. It was in October Sky. Very similar sequence where they had the sounding rockets failing on them. I think they chose that song as well. Okay, good accumulator equalization. We got good temperatures. Are holding very nicely. Got good stuff all around. Go ahead and reset. Okay, we're good. All right, H2 purge. with some mild time acceleration. That's how I'm getting through the purge so fast, if anyone's asking. If for whatever reason something you feel like is happening a little fast, check up in the top right. I always have time acceleration indicated. You know, I never lie to people about how long these procedures take or my use of time acceleration, because I'm not here going to sit, you know, 200 and some odd hours for a whole mission. I just don't have the time. I would love to. I simply do not have the time. Okay, H2 purge heater off. Let's go ahead and start pressurizing the lunar module. We shouldn't have much, just a little bit of differential pressure here. Let's go ahead and open that bad boy up. And hatch is open. Okay. Last step here is just waiting on an uplink, and we'll get to the LEM. We are boarding Snoopy. Houston coming at us with that uplink. There we go. P22 auto optics. And a state vector update. Oh, very nice. What a coincidence. We're about to have T plus 98 hours. Oh yeah, not too good for the lungs. Although macroscopic, so that's nice. It could be worse. Could have been asbestos. What else are we getting? LLS2 reps, Matt. Okay. That's Lunar Landing Site 2. Uplink complete. Going to go ahead and copy down this pad real quick with the old snipping tool. And a map update. There we go. Let's get in the LEM now. We got everything we need. We are given the go-ahead. Great. First things first, we have to remove one of our crew members from the ECS display. Crew in cabin will now be 2. We'll connect the CSM O2 hose. And we will go ahead and open the lunar module hatch, which, unfortunately, has to be done from inside the lunar module. Slightly unrealistically, but required because, well, you can't simulate this type of interaction between multiple vehicles like that. So we've got that hatch opened up. Nothing else to do here. Add lunar module pilot to the cabin. There'll be 1 in the cabin now. We'll set floodlights to all. Descent H2O open. Descent O2 open. Cabin repress auto. Repress circuit breaker close. And transfer to lunar module power. Or delta gives us 0 volts. That's good. Lunar module is off the line. Cross tie or cross lunar bus tie closed. Cross lunar bus tie closed. Window shades down. Ooh, that's the view. That is the view right there. A nice screenshot. EPS activation. Annunciators and numerics are bright. Signal conditioner 1 closed. Descent ECA control closed. Signal sensor closed. PCM telemetry closed. Signal conditioner 2 closed. Electrical power system display. Descent ECA control. S-band transceive. Intercom system transceive. COM display closed. System engineer audio. Primary S-band power amplifier and transceiver. A la the transponder. That's what we would just call those these days. S-band antenna close. Pre-modulation processor. Modulates pulse modulated. Transceiver and power amplifier on primary. Down voice backup. Pulse code modulator and ranging. S-band antenna is selected aft. Com check with Miss Finn. We'll need to wait for a lock here. Yeah, I love the lunar module layout. It's just so user-friendly, with the exception of temp press mon and temp press mon. Yes, only exception to that rule. Voice check is A-OK. Low batteries, descent bats gray. Low voltage taps. EPS cross tie balance loads open. Let's get high voltage tap selected. So we reset on the tap that we want to use. So not on low voltage, but on high voltage. We reset on that tap. And on. Reset. And on. Reset. And on. Reset. And on. Close the balance loads. We have that open because as we reset and turn those batteries on, the voltage and the amps are going to go up and down and up and down and up and down. And we don't want to balance the loads because it could cause some issues. So we open that up And then we just have 2 of the batteries go system engineer, 2 of them go commander bus. We just have those on their respective buses. We don't want to distribute those fluctuations. AC bus tie for the inverters, both A and B buses. We'll need the voltmeter for the AC. And we'll close inverter 1 to test that it works. Close inverter 2. AC bus is selected. Select inverter 1. Voltage in the green. Inverter 2. Voltage in the green. Okay. Open up inverter 1. And let's get that mission timer activated. We'll need numerical lighting. And of course the mission timer flight display. $10, $20, $30, $40, $50, $60, $70, $80, $90. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 94, 44. So that's 5, 4, 3, 2, 1. Mark. One second behind. Increment that up one. There we go. Now 1 second ahead. That's better than behind. This is NASP. It's a mod for Orbiter. A study level simulation of the Apollo spacecraft. We are flying the actual Apollo guidance computer and lunar guidance computer software that have flown on this mission in real life. We are flying the exact flight profile, the exact flight plan, everything down to a T. At 9451 here, we'll start up our primary glycol loop, and we'll get a checkout of our caution warning electronics and annunciators. This is NASP. NASSP, that stands for NASA Apollo Spacecraft Simulation Project. It is a mod for Orbiter, now on version 2024. Okay, environmental control system display. Close glycol pump auto transfer. Pump 1. Open auto transfer. Go ahead and select pump 1. Like music to my ears. Wow, where did all of our water in that ascent tank go? You know what? I bet it was purposefully under fueled for this mission. That's right. Glycol pump 2 close. Auto transfer close. Alright, caution warning, checkout time. Circuit breaker lighting, master alarm, and seaweed and my ears, good lord. Yes, I'm running Orbiter 2025, but not the most recent version of it because I frickin' hate the UI on the new one. I'm sorry, but it's god-awful. Okay, we should get LGC, CES, AC, and DC, RCS regulator A and B, and then ascent pressure, obviously that's a given. We should get heaters, preamps, and ECS. We should get H2O SEP light. Why do we have the water quantity? Ascent water is closed. All ascent feeds are closed. Interesting. Okay, heaters display close. ATCA closed. Engine control closed. RCS heaters to auto. but we don't have those circuit breakers closed yet. Those will come up later. Rendezvous radar temperature, check. Landing radar, check. Quad 1, 2, 3, and 4 are obviously very cold. S-band, check. Landing radar. Lamp test, alarm, tone. Caution warning 1. Bank 1 is check. Engine push button start, check. Bank 2, check. Bank 3, check. Bank 4, check. Component lights, check. Evap flow 1 open. NASSP. That would be the latter of your two options, yep. Alright, circuit breakers time. One of my favorite procedures. I just find this step to be so satisfying. Ew, bleh. Nope, I hate ketchup. It is nasty. Barbecue sauce is where it's at. I like spicy ketchup, not sweet ketchup. Blech. It's actually not that confusing. You just need the Orbiter x86 files, Orbiter x64 files, and the NASP. All you do is you unpack the x64 files into the x86 files, overwrite you do that in the root directory, and then you do the same thing with the NASP install, right to the root directory and overwrite, and boom, you've got it installed. Pretty easy. Talkback verification. Fuel and oxidizer talkbacks. On the vent. Yep. Those two are gray. Landing gear deploy talkback barber pole. Ascent regulators 1 and 2 gray. Only 1 gray. 2 barber pole. Barber pole. Barber pole. Gray. Barber pole. Alright, pings turn on and self-test. CDR bus is good. System engineer bus is good. If standby light, proceed. No standby light. Verb 36, enter. Verb 21, noun 01, enter. 3000, enter. 1672, enter. Enter. 333, enter. 10000, enter. Inertial measurement unit operate close. Yeah, this light will remain on for 90 seconds. Verb 35, enter. Good test. I will just time skip till the IMU is fully powered up. Okay. 20 seconds later. There we go. Reset. Verb 37, enter. 00, enter. Verb 25, noun 01, enter. 1365, enter. Enter, enter, enter. Verb 15, noun 01, enter. 1365, enter. All balls. Verb 21, noun 27, enter. All sevens, enter. Register 2 is greater than register 3 within 78 seconds. Very good. Verb 21, noun 27, enter. 0, enter. Crew in cabin 1. Crew in cabin 2. We're a little behind schedule here, but we should be able to recover. Suit flow, actuator override, actuator override, suit gas diverter push, press regulator A to egress. Alright, suit fan number 2. Excuse me, selector. Duh. All right. P52, IMU preferred. Let's just go ahead and copy that DAP pad before it disappears. $194.9. And 351.9. All right, just a little IMU align here to LLS2. Looks like there wasn't much of a change between the previous refs mat and this one. But we always do a little bit of a correction here when we get to the lunar module day, even if it's just like 1/1000th of a degree. Want to make sure that we've got as good an alignment as physically possible on this hardware. See, 400ths of a degree off. Very good precision. Okay. GDC alignment is good. Thruster C4 and B3 off. Next up, H2O separator check. Suit fan 2 open. Suit fan 1 close. Push for separator 1. Select suit fan 1. Suit fan 2 close. Secondary transponder and power amplifier check. We're just gonna go ahead and verify high voltage taps here. Wait for relock. Good relock. Voice check complete. Good S-band temperature. Going to primary voice. Glycol pump check. Alright, so this is just pump 2 and auto transfer handover check. Good. Secondary glycol or instrumentation loop only. Very good. Auto transfer open. And pump 1. Alright, glycol checks are good. Let's go ahead and remove Lunar Module Pilot from the cabin. Switch to Command Module. Add them in. Configure VHF-B simplex. B data. VHF-B activation and checkout. Oops, that's A. Alright, VHF-B simplex check is good. VHF-A simplex check. VHF-A checks complete. Alright, LGC clock sync. Verb 25, noun 36, enter. Verb 06, noun 65, enter. So that's 95, 13, 38, 95. So plus 00095 plus 00013 plus 03895. Verb 06, noun 65. Enter on both computers at the same time. 90.53. Or 50.53, that is. We do 60 minus 50.53 plus 19.08. And that gets us an increment of 28.55 seconds. $14.50 and $14.51. That is good enough. Gonna load the time of ephemeris into the computer now. 6. Alright, verb 74. Looks good. S-band antenna pitch plus 90. Yaw 0. Tracker mode slew. Biomed off. Bitrate low. Select forward. Down voice backup. And let's go ahead and get ourselves maneuvered to docking attitude. All right. While we're maneuvering to docking attitude, let's go ahead and transfer the lunar module pilot over back to the lunar module. Alright, now we're just making our maneuver here to our docking attitude, and we're going to do the docked IMU course align, which involves some very mild arithmetic, but nothing too serious. Any questions so far? I know we had to kind of speed it up a little. We were a little behind schedule, but we're right on track now. Everything is coming up roses so far in our mission. I make a save before I jinx myself on that. It could be a little loud in the lunar module, so let me know if you need me to turn it down. Look at that, staring right at the lunar surface. We're gonna get really close to that baby today. Yeah, how is that, Jackson, so far? Does that answer some of your questions you may have had about the lunar module? Is there anything coming up you want to know about, or anything that I did you wanted to know about, like what the time of ephemeris is, or you know, any of that jazz? It was pretty straightforward. Yeah, see, I know. Aside from the amount of switches, like, things are straightforward. Pretty basic stuff here in the LEM. Where the LEM lacks in the sheer systems complexity of the CSM, it more than makes up for in the sheer complexity of the guidance, navigation, and control system. You may hear me throw around a couple explicatives later about how I seemingly don't have rate command when I think I should have rate command. Mostly because I'm on keyboard and mouse, and that doesn't really translate too well to a spaceship, but there's quite a few controls, because when you're on, for example, when you're on computer control, or pings as it's called here, set by this switch, these 3 attitude control switches do different things, and get this, they do different things when they're set to auto, or at hold, or off. And they do different things depending on if you've got verb 77 or verb 76 punched into the computer. And get this, on guidance control eggs, which is this little baby right here, my beloved, these three switches do different things, and they do different things depending on this switch right here. So it can get a little confusing at times in regards to the way that the spacecraft is supposed to be behaving. So, exciting times, exciting times. We should be just about in our, yep, right in our docking attitude. Perfect. Now this one, we do want to stay pretty nicely aligned. But you'll notice something interesting throughout that entire maneuver sequence. Our pitch rate, our roll rate, and our yaw rate showed basically 0 that entire maneuver. And I'm gonna let you guys put your best guess as to why that is. Yes, it's correct behavior. I want to see if you guys can come up with a solution as to why that might be the correct behavior. So, throw your best guesses. But I will give you a hint. It does have something to do with the fact that we are docked. That is your hint. As a matter of fact, I could make a poll. Let's try that. Never done that before. Let's add poll. Why did they show nothing while maneuvering? Is it A, the LEM RCS wasn't firing, B, the rate gyros aren't powered up, C, center of gravity effects, or D, sensitivity was too low. As in, it's moving too slow to be picked up on these needles. Actually, moving too slow to be picked up. Alright, best guesses. Best guesses. If anyone has seen Apollo 13, they may know the answer. That is your second hint. If you've seen Apollo 13, you might know the answer. It's like flying with a dead elephant on our back. Exactly. Exactly. So it's a fair guess. It's a fair guess. And I will tell you that you are actually correct. It is the center of gravity. Unlike the command module, the rate gyros are not powered separately from the IMU. They are powered together. So as soon as I close that IMU operate circuit breaker, our rate gyros also power up. While the spacecraft is docked together, the center of gravity is pushed into the command module. And so we're rotating about the center of gravity. And that means that any change in our direction to the IMU is actually seen as a translation. And if you watch Apollo 13, you'll know that to pitch up, they had to translate forward. To pitch down, they had to translate aft. To roll right, they had to translate to the right, and to roll left, they had to translate to the left. And translations are not something that are picked up on our attitude rates. So it is actually the center of gravity effects, reading those as translations and not rotations. Yep. Yep. So usually, the center of mass in the LEM, or the center of gravity in the LEM, is going to be, you know, about the center when the descent stage is attached. However, when it's docked like this, because the service module is so heavy, it pulls that node all the way back here. You know, slightly forward of here, which is where it would be with the CSM alone, slightly forward of that, because the lunar module is attached. But the CSM is so heavy, it pulls it right back into that command module, and now we translate along this pivot point instead of rotating along this pivot point. So, good answer, good answer, good answer. And it is officially docked IMU course align time. CSM is holding attitude minimally. Verb 06, noun 20. Enter. That will be 300 minus the current roll angle. So 300 minus 359.68 gives us negative 59 68. 360 minus 59.68 gives us 300.32. 180 plus 269.59 minus 360. That gives us 89.59. And 360 minus 0.47 gets us 359.53. Verb 41, noun 20, enter, plus 30032, enter, plus 08959, enter, plus 359.53, enter. Oh, 100%. 100%. One of the things I really like about KSP is its CG, right? Things in KSP they're naturally flimsy. They are naturally flimsy, right? Things are not as rigid in KSP as they would be in real life. But that does give you the greatest appreciation for center of gravity. It really, really does. I suck at KSP, but I watched enough of it to know its peculiarities and the things that I actually do like about it. Verb 25, noun 07. We're going to go ahead and set our refs map flag. Since we did not use program 51 to determine our orientation, we are just going to go ahead and set the fact that we actually did use it. And because Houston already knows what refs mat it is, which is that it's identical to the CSM one, we actually don't need, you know, to uplink a different one. They just will calculate based on that. And there you go. That sets the refs mat. Now we just go verb 06, noun 20. Hit enter on both computers at the same time. And we just go ahead and verify our angles are looking pretty nice. Just a little tiny bit off, but nothing that won't get fixed later in the final line. ECS battery activation and checkout. This will give you an appreciation of DC power. BAT5 normal feed on. Volts lower, amps rise. System engineer bus. BAT6. Normal feed on. Off. 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 Beautiful. 1, 2, 3, 4. No current. CDR bus is good. System engineer bus is good. Backup feed on. On. Off. Off. CDR. Systems engineer. Battery current. And we are go. Explosive device, batteries. Bat A is good. Bat B is good. And we will now close up that LEM overhead hatch. Yes, let's actually, here, let's try this. I never tried a Q&A before. You put up your questions there, and I'll try and get them answered for you, if I can. And venting the tunnel. Ah, the difference. It depends, actually. For example, on pings, which runs through the LGC, when you move the control stick, commands will be passed through the computer directly to the RCS most often. And if you're on mode control, that's a bit like your rate command. You're on pulse, you do pulse jets, you know, puff, puff, puff. And if you're on direct, it actually doesn't do anything at all. If you're on verb 77. If you're on verb 77, I don't even think pulse mode will actually work properly. All of that gets confusing when you introduce ACA 4 jet enable and disable. When you're on verb 76, mode control will basically become your pulse mode. So again, direct in this instance is actually honored. On AGS, all of these do exactly as advertised. Auto will always be automatic control. This is like you hit verb 49 and you pro on the CMC. Right when you flip it to auto, she's immediately going to drive to attitude on mode control. At hold is like your CMC hold mode. So it just is, do those controls go through the LGC or the AGS? That's the biggest difference, but you'll be seeing them, how it behaves quite a bit in this mission. A lot of this stuff is stick flown compared to you know, Apollo 11, which does have quite a bit of auto maneuvering in it. Got good stable pressure here, good integrity in the tunnel. Go ahead and vent the rest of the way, shall we? Ooh, the surface, we love it. All right. CDR and LMP are now going to don their helmets and gloves. They will be added to their suit loops. Our next step will be the ARS PGA pressure integrity check. We get a few moments to enjoy the view out of the window. That is very interesting to think about. However, if you do the math, it checks out. Like, once your blood is denitrogenized, you're good. You know, you can survive off this. However, that does mean that 70% nitrogen, which is found in the suit loop, you know, after launch, because it had Earth environment atmosphere in there, that's deadly. That is deadly. So I believe they may have purged this out with pure oxygen prior to liftoff at some point in one of their tests, most likely. Though it was a question that I actually posed yesterday, and it is something that I'm in the middle of researching, so I can't give a definitive answer to that at the moment. But I did find that the suit loop comes pre-pressurized, and I'm interested about where that nitrogen that was there has gone, or if it's even there at all. We are now tanking up the suit pressure up to close to 9 psi here. And this is to run an integrity check of our suit loop, make sure that we don't have any leaks in it. This is standard on every LEM flight. Stationeers does actually simulate that, believe it or not. Too high of a nitrogen atmosphere can be deadly at low pressure. It does not, however, simulate too high of an oxygen environment at high pressure. That it does not simulate. For whatever reason, you can breathe perfectly fine in that environment. No, you can have nitrogen in your suit. It doesn't go anywhere. You breathe it in and you breathe it back out. You just need to have the right pressure, and it will remain in your suit loop. You can have it there, you can leave it there. As long as it wasn't deadly to begin with, you'll be okay. Some funny render distance shenanigans happening outside that window. All right. Don't know why that kept going up for a little bit after I closed the regulator. That was a bit odd. but the pressure is holding and the regulator seems to be working now. Could have just been most likely temperature rising. If I had to guess, our temperature is low, and of course any sort of rise in such a system will increase the pressure. No, I've seen it been done. Okay, good integrity on the secondary CO2 scrubber. Back selected to primary. Suit circuits relief now to auto. Regs to cabin. Cabin gas return auto. Push. Cabin fan control close. LMCM delta pressure, that is reading the maximum. Very good. Funnel vent off. Funnel lights off, and we'll pop on those AC roll jets again. And switch to Omni Charlie. Now up to our cabin regulator check. Pressure equalization complete. Yep, that valve is closed. Tunnel vent valves closed. Tunnel is vented. Cabin gas return to egress. That should pop that out. Nope, actually it happens when we get to here. Alright, press regulator B to egress. There we go. Yep, that's good. Forward cabin dump valve open. Standing by for master alarm. There she is. Auto repressurization. Very good. Pressure regulator A, close. Cabin repress, close. Forward cabin dump valve, open. And take it on down to 3.5 psi. .5. Ah, the pressure was set to 100 kPa for all. Yeah, that, okay, yeah, that might be. Press regulator B, close. Suit circuits relief, open. Down to 3.5, very good. Suit circuit relief, auto. Press reg B to egress. Alright, good suit pressurization. Good cabin pressurization. Cabin gas return auto. Gas diverter push. And we will go ahead and remove the astronauts from their suits at this time. What a beautiful view. Control point 2, we're flying over it right now. Coming up on Misfin acquisition. No, your suit tank needs 100% O2. The N2 in the suit from opening your helmet, that's okay. So you can have nitrogen in the suit, but it can't be in the tank. Then you would be correct. Yes, the nitrogen would slowly displace the oxygen. But you can have nitrogen in the suit as long as the tank is pure. Okay, standing by for acquisition. Madrid and Goldstone will be having us today. Acquisition Madrid. And there's the old DAP pad. Go ahead and copy that one down. This one's for the LEM. Very good. Yes, that is not what I initially said, but I corrected myself. If you have nitrogen in your suit, you are okay, as long as the tank is pure oxygen. You can't be adding nitrogen to the suit. Alright, stabilization control, AEA. I think it was this circuit breaker. Yep. Egg status operate. Get another master alarm there. Oh, hey, look. DITA address cue card. That's actually kind of cool. Caution warning reset. That would be 000 plus 888888. Good. 1, 2, 3 minus 4, 5, 6, 7, 9. Good. All keys tested. 4, 1, 2 plus 1, 2, 3, 4, 5. Sure. 4, 1, 2. Readout. Alright, self-test satisfactory. 574. Descent stage not staged. 604. Not on lunar surface. Good. 612. Staging sequence counter 0. Very good. B-22, orbital navigation. Speed will be medium. 0 switch off. On CMC. Verb 37, enter. 22, enter. Proceed. This will be a known landmark. And its coordinates are 01266 11839 and 00173. Just waiting on that T2 time for our tracking. Which is 965102 for landmark 130. Wow, there's a lot of landmarks in Apollo 10. You really don't realize how many of them there actually are in this mission until you're flying over and you can see a bunch of them. And Mount Maryland, that's just an astronaut named feature, so not a part of this mission, but named by Jim Lovell on Apollo 8. I totally forgot how all of these astronaut features got their name. Beautiful track. Mark. 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 And there we go. Proceed. 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 And what do we got? One, 2, 7, 8 as opposed to 1, 2, 6, 6. We've got 1, 1, 8, 1, 8 as opposed to 1, 1, 8, 3, 9, and minus 0, 3, 6 as opposed to minus 1, 7, 3. So very, very close overall. I am very happy with that. We will exit P22. High gain antenna pitch, minus 45, 353. React, select high gain, and just waiting on the old maneuver there. S-band pitch will be about 193. And 64. We're now just pretty much waiting on the completion of this maneuver. Track mode auto, biomed left and high, voice to voice, docked IMU final line, plus 00045, minus 00030, minus 00072. Enter. And that is complete. Verb 16, noun 93. Pulse drive complete. Verb 06, noun 20. Very good. Let's just double check that information. That information tracks as accurate. Let's accept that uplink. This uplink is our refs mat directly into the current slot, not our desired slot, but our current slot. And that is basically just saying that, hey, our current orientation is in reference to this landing site. And we know that because when we did the alignment in the command module, the command module's reference was referencing the landing site. Of course, we will not actually be landing, but we'll be getting very, very close. And then we will be getting very, very high off the surface. Higher than the command module, actually. We're currently powering up the lunar module as we speak. We're on flight day 5, powering up the LEM for undocking and LEM flight. Uplink complete. So that's 7 times 60 plus 5, 30.53 over 60. So that's 377 plus 0.07225. Mark. That is a 90-hour bias, although I will say that I do prefer to have an actual K factor, which sometimes does not come up, so we are going to calculate our own K factor. They wanted a 90-hour bias. That would be, yeah, 7 by 60. Excuse me, I made a typo. Plus 5. That's 425. 425, 5. So 7 by 60 plus 6. So 426, 5. There we go. Made a typo in my calculator. That's why it's always good to double check your math. Mark. Okay. Verb 47, enter. That's 90, 0, and 0.66. 414 plus 1. All right, we got ourselves a separation pad. Let's go ahead and record that. Undocking at 9820, so we're very close now. Ooh, my favorite command in the Lunar module, 400 plus 3 on the ags. Whoop, and that is that. This will be our LEM and CSM state vectors uplinked to the computer. Yeah, we are very, very rapidly approaching our undocking time now. That didn't feel as long as it probably took. We're probably 2 hours, maybe 2.5 into this stream. So, yeah, it definitely feels a lot faster than it's actually going, that's for sure. .207. We're gonna do this as best as we can. So that's 210. So 207 is gonna be just under that. About right there, if I had to guess. Actually, probably just a little bit more up, just for factoring in distortions as you get close to the 90 degree yaw mark. 208. Bump it up just a little bit more. Looks good. Make sure this matches. So that's 317. Should be 0. And 440 Should be 0. That is good. Proceed. Now we're standing by for our eggs K factor and our DAP set gimbal throttle check. One of my favorite procedures. Unfortunately, always happens on the flippin' dark side, so we can't watch the engine bell move from the outside of the spacecraft. I think Apollo 9 was the only time it happened in that frickin' daytime. Oh, such sad. Probably other missions, but 10, 11, and 12, it always, for me, happens on the nighttime. And we've got our K factor. Go ahead and do our DAP set gimbal throttle check. Deca power, close. And then, actually, let's just go ahead and record that K factor real quick. Mode control pings to auto. Throttle manual, CDR. PTCA minimum. Verb 48, enter. Verb 21, enter. 32012, enter. Proceed. Our spacecraft weights are 31532 and 37988. Proceed. Pitch and yaw trim are going to be +6 and +6. They are unset for this phase of the mission. Engine arm descent. We get the descent regulator warning light. That's perfectly okay. And interestingly enough, we actually bypass the trim check here. Okay, TTCA minimum. Throttle up. Soft stop at 50. Hard stop at 98. Throttle down. Soft stop at 50. Then minimum 10%. Engine arm off. Descent regulator light will go out automatically. Misfin verifies GDA position. Throttle control auto. TTCA jets. Mode control pings to off. So, go ahead and actually cycle that. There we go. Verify our RCS valves line up with the panels. All barber poles, very nice. Close, open, open. All grays. Temps, good. Good, good, and good. Helium. Good so far. Propellant. Meets pre-press conditions. That's good. Fuel manifold. Oxidizer manifold. Very good. Go ahead and pressurize RCS. Arm the explosives. RCS fire. Close, close. Good pressure. Master arm off. Good oxidizer manifold. Good fuel manifold. Good propellant pressure and temperature. And good helium pressure. Okay. RCS checkout. CSM in minimum deadband hold. Verify DAP 32012. Okay. Maximum impulse. Verb 15. Noun 01. The answer to life, the universe, and everything. Alright. 2 soft stop, then pause at null. Roll right. Good. Roll left. Good. Pitch up. Pitch down. Yaw right. Yaw left. Very good. Entering a maximum deadband. Get a little bit more light up here. It's just a wee bit dark. CSM roll jets off in wide deadband hold. Tunnel vented to 0. We are check. Minimum impulse. Verb 11. Noun 10. 31. 67777. ACA cold fire. CES voltage. Guidance control AGS. AGS attitude hold. Mode control, mode control, mode control. ACA 4-jet enable. Deflect slowly to hard over. Pause at null. Okay. Roll right. We're good. Roll left. We're good. Pitch up. We're good. Pitch down. Good. Yaw right. Good. Yaw left. Good. Pulse, pulse, pulse. PCA breakers in. Cycle Seaweed. Cycle heater quads for ooh, that light is still on. There we go. Hot fire on pings. Verb 11. Noun 10. Enter. 5. Enter. Guidance control to pings. Translation mode.
Translation.
Translate up. Down. Good. Right. Right. Left. Forward. Aft. Verb 77. Enter. Switch to CM. Transponder power to heater. Enable all roll jets. right, don helmet and gloves. 300 is cabin flow. 302, cabin flow. Suit circuit return. Push. Pressurize up. About to get suit compressor light. And O2 flow highlight. Woo! Alright, how long has this been going? Oh, there we go. We're at 2 hours, 7 minutes. Yeah, holy smokes on Lem power up, huh? And that's with time skipping. That is with time skipping. Yeah, that's good. Okay. Left suit flow. Full flow. And depress. Test off. Good on those. We are approaching the final tests and deployment of the landing gear. How's everyone feeling so far? Kind of a lot to go through, I know. Alright, slew left to mode 1 region. Okay. Mode 1 region. Up. Down. Left. Right. Looks good. Up. Down. Left. Right. Looks good. Rendezvous radar auto track. Radar test rendezvous radar. Got good response on the cross pointer, good response on FDAI, and good response on tape meter. Good lock. AGC brightness. Good. Transmitter power is good. Shaft error. Good. Trunnion error. Good. Set the Norman flag. That's verb 25, noun 07, enter. 101, enter. 10, enter. 1, enter. Rendezvous radar to LGC. Good response from cross pointer and tape meter. Verb 63, enter. Proceed. Good response on those angles. Tracker light should be on for a couple of seconds. Tracker light out. Good response from cross pointer and tape meter, and FDAI is good. AGC brightness is good. Proceed. Data coming out, we should be 195 on the range. Good. Range rate will be 488. 486 actually, but that's close enough. Verb 34, enter. Good response. Radar test off. Verb 40, noun 72, enter. And we'll course align to the stow position. Proceed. And radar checks are complete. Open, open. Verb 44, enter. Go ahead and break lock with the S-band. Verb 48, enter. Verb 24, enter. 21112, enter. 11111, enter. Pro. Verb 46, CMC auto. We can take these off. Verb 49, enter. Verb 25, enter. Plus 18000, enter. Plus 01400, enter. Plus 01400, enter. Proceed. Proceed. Spacecraft now maneuvers to eggs cal attitude. Very small maneuver to eggs cal attitude, just roll 180 and a little bit of a yaw here. I'm gonna go grab some water. I do not think that we are going to get to undocking today. Unless people really want to get to undocking today. But we've been going on for quite some time. If we start the LEM mission now, like, we're gonna be here for a long, long time. So I think LEM power-up is pretty much, you know, where we're going to stop. We've got a few more tests to do. We've got to pressurize the dips. Deploy the landing gear. And then after that, it'll pretty much be performing some undocking checklists. And right when those are finished out, there'll be a smidgen of time between the completion of those checklists down to the line and then the actual undocking. And that is probably where I'm going to end, because that's the only reasonable time to end. It's either I have to finish LEM power up later, which takes time away from the actual flight and the mission that people really want to see, or I have to, you know, be at a bad spot for loading up, which is definitely not a good alternative. So while we're making our maneuver, I'm gonna go grab a drink. I'll be back. Water is good. Water is good for you. It's good stuff. Look at that beautiful, not visible landscape beneath us, but you could just see just stars and then darkness. The darkest dark imaginable. I really like the lunar module. Power up, yes, it takes a little bit of time, but it's just so worth it. I like the whole power up sequence and plugging in all those circuit breakers. It's a really satisfying sequence. quite good. And that maneuver is almost complete. $175, 180 right here. Stabilize out. And let's read our accelerometer bias coefficients. Roll is good, or that would be, oops, one, there we go. X, Y, and Z accelerometers are good. We go gyro drift coefficients, here we go. That's roll is good. Pitch is good. Yaw is good. Verb 16, noun 20. That should be less than 0.1. So these guys, less than one of those a second, and we are good. Verb 40, noun 20, zeroes out the IMU coupling data unit. We will go CMC free. LEM and CSM thrusters are disabled. 400 plus 6. And that'll kick off our calibration. Twenty, 21, 22, 23, 24, 25, 26, 28, 29, 30, 31, 32. All right, accelerometer bias coefficients are good. X-axes, Y-axes, Z-axes, all good. We're just waiting on those gyro drift coefficients to finish up here. CMC auto. Go ahead, start up dips pressurization and check out. Ambient helium pressure is good. Supercritical helium pressure is good. Descent helium regulators, Reg 1 gray, Reg 2 barber pole, very good. Master arm on, propellant isolation valve fire, and safe. Descent start, fire. Good pressurization, and safe. Master arm off. Descent 1 and descent 2 are good. Ambient helium pressure is good. Supercritical helium pressure is good. Dips pressurization complete. Do some very, very light time skipping here. Waiting up for the calibration of our eggs to finish. Calibration complete. Let's read those gyro drift coefficients. Roll, that's good. Pitch, that's good. And yaw, that's good. And maneuver to undocking attitude. Rendezvous radar transponder self-test. Transponder power is on. Transmitter out power is good. Rendezvous radar transmitter AGC signal test. That's good. Operate. That's good. Return frequency or rendezvous radar transponder return. Excuse me. Return. Jesus. Frequency lock is good. That's B. And we're good. Deploy landing gear. Yeah, I think it'll be kind of a treat to show you this through the window. Because you can actually see it. Whoop! There we go. Awesome. Safe that. Talkback is gray. Master arm off. Landing gear flag off. Telemetry bitrate high. Let's go ahead and get that eggs calibration. And they did come back and actually update our K bias. Our K factor was actually 0.68. Yeah. $196. That's 80. $196. 317 should be 0. 440 should be near 0. Very good. Proceed. And that finishes Lunar Module power up. We're pretty much down to the undocking checks. And that's gonna do us for the day. So right when we get in, we're pretty much gonna finish off with these undocking checks, and we will get right to the mission. So kind of a little bit of a flightless stream today, just entirely focused on lunar module systems. But I hope you all still enjoyed anyways. So next time we'll continue flight day 5, and we'll do the lunar module mission. Thanks, guys, for coming around, and I hope to see you in the future. Goodbye.